Hey everyone, and welcome to our lecture on Chapter 1. So this chapter or this lecture is primarily intended just to give you a primer on some of the material we're going to be covering in the course, make you familiar with some operating system concepts, some open source concepts, talking a little bit about what is Linux and some of the different distributions and things like that. So you'll notice that there are no quizzes or labs associated with this lecture, really just designed to give you some background information. So let's go ahead and get started. An outline for the chapter. So we're going to be talking about what is an operating system, investigating user interfaces, how does Linux fit in the OS world, and what is a distribution. Okay, so what is an operating system? Well, an operating system has something known as a kernel component, and then it's also got something known as a user space component or additional components. So what is the kernel? Well, the kernel is software that's responsible for interfacing with hardware devices. It's also used to do things such as allocating memory for different programs, scheduling the CPU time, make sure that everything's fair and that programs get a chance to run on the CPU, given the ability for programs to interact with each other. And it's important to note that kernels are not interchangeable. And what this means is that the kernel used in Windows, Explorer.exe, is not interchangeable with the kernel that's used in Linux or the kernel that's used in OS X. Now, with that said, there are many versions of the kernel, and we can compile kernels, different versions for Linux, and those are interchangeable. Okay, so the Linux OS kernel is really what Linux is. In fact, sometimes you'll see Linux referred to as GNU Linux, and that's because Linux is the kernel, but GNU is the user space applications that you use in order to actually have a functional operating system. So development on Linux started in 1991 by a student named Linus Torvalds. And today that runs on many various platforms and hardware. It's a very popular operating system. So it's probably more prevalent than you think. A lot of TVs and smartphones, um, any sort of smart devices, IoT devices, they are based on, or usually based on, a Linux-based operating system. And something I want to share with you is the first post that Linus Torvalds made when he was reaching out and trying to let people know that he was working on Linux. And I think it's funny, he says, hello out there, everyone using Minix. So Minix was a Unix-like clone. I'm doing a free operating system. It's just a hobby, won't be big and professional like GNU, for 386, 486 AT clones. So those were computers or processors back in the day. So this has been brewing since April and it's starting to get ready. I'd like any feedback on things people like or dislikes in Minix, as my OS resembles it somewhat, same physical layout of the file system due to practical reasons, among other things. I've currently ported Bash and GCC, so these are two software packages, and we're going to be using Bash extensively here in this course. Um, and things seem to work. This implies that I'll get something practical within a few months, and I'd like to know what features many people would want. Any suggestions are welcome, but I won't promise I'll implement them. So I just think it's really interesting that Linux started out as just a hobby, just something real small, never intended to go professional or big, and now it absolutely dominates the internet. It dominates server operating systems, dominates embedded devices. It's just really prevalent in the technology that we use nowadays. Okay, so what about these additional components, right? What else do we need for an operating system? We need more than just the kernel. We need things like command line shells so that we can type commands. Uh, GUIs or graphical user interfaces so that we can use a mouse and move windows around, point and click. We need some utility programs, things that allow us to copy files, move files, maybe format uh, hard drives. We need libraries, so code that provides functionality for other code or other programs so that we can share functions and routines. And then also productivity programs. Like, what makes computers actually useful is the fact that we can use web browsers and office software like Word and Excel in order to accomplish things. Now, there are a few different user interfaces when we use an operating system, and the one that I want to focus mostly on in this class is the text mode user interface, because this is the one that usually scares people. You sit down and it's just all text on the screen. So an example would look something like this. We come up to a login prompt and it's letting us know what version of Fedora it is. It's letting us know what kernel it's running. The name of the computer is Essentials, and it's prompting us for a login. So we're going to interact with this particular um, user interface via text. So we're going to type into it with the keyboard and then we're going to read the response. So there's no graphics involved with this one. After you log in, you'll end up getting a shell prompt, and from there you can interact with the operating system. So we need to become familiar with some of the commands that allow us to interact with the operating system, traverse the file system, create files, move files, and run programs. So an example is the ls command. The ls command, what that does is it lists out the contents of a directory. So if you think about, if I open up like a file explorer and I'm looking at my documents folder, if that's where I'm located and I type in ls, then it's going to show me all of the files there. And it might be something like this Word document or this TIFF image. Okay, so commands display information and immediately return a prompt, or maybe not. Maybe they just run, um, and then when they're done, they come back to the prompt. Okay, so we can see that there. We typed ls, we get some information, and this $sign is representative of the command prompt, is waiting for us to type something in, another command. So one of those examples of a maybe not, maybe when it doesn't return right back to a shell prompt, maybe it actually opens up a program and we interact with that program. So an example of that would be Nano, and Nano is a text editor that we can use in the terminal. We can see that here, and we're going to get some practice with Nano later on this semester, particularly Nano and VI, two very popular text editors. But you can see this is a text file that's opened up. This is actually this is test.txt, but it looks like it's a copy of the /etc/fs tab file, which is our file systems that get added to the operating system, or as we call it, mounted in the Linux world. So we can type into here like we would in Notepad or TextEdit on Mac. And down at the bottom, we have a legend of some of the commands that we can use. So keep in mind, text user interface, there's no mouse involved. So we're just using the keyboard. And we can use this legend down at the bottom. The carets that you see here are the control key. So to get out, we would press Control X and Control O to save the file. And some of these other things like cut and uncut and stuff like that. Alright, so next let's look at graphical user interfaces. This is probably what you're more familiar with. Hopefully you got Ubuntu installed, and when you get that installed and you boot it up the first time, you're greeted with a login prompt or the login screen. This is a login manager, and what it does is it allows us to pick our user account. So this one has Rich Blum as one user account, and it has the option to log in as a guest. So this is very similar to the way that the login manager works in OS 10 or Mac OS and Windows, in that we just put our password in, press enter, and if it's correct, we'll get booted into the operating system. Alright, so this is another example of a graphical user interface. This is a distribution that we're not going to be using this semester, but it is one of the more popular ones, OpenSUSE. So OpenSUSE is using, this is the KDE GUI, the KDE UI, and we can see it resembles Windows really closely. We have this sort of notion of a start menu down here, and we click on that, and things are broken down into categories. We can find our computer, we can shut down, and open windows are shown down here in the taskbar. Just to show you what some of the other desktop environments look like, we have Fedora here. So Fedora is one of the VMs we're going to be using, and it uses GNOME 3. So GNOME 3 is a little bit of a newer UI, and it works really great on tablets. It doesn't have that notion of the start menu down at the bottom. We have activities up here at the top, and we can click on that, and we have this sidebar. Sort of reminds me of Mac if you put your dock on the side. We have the ability to search for different programs, so something for email, we might use the Evolution program. And if we open up any windows, you see we basically use one window at a time. We can use other windows. We can just come in here and we can see there's a line under here letting me know that I have a Firefox window open. There it is. Let's also open up a file explorer just so we can see what a couple open windows looks like. Okay. And if we come back over here to activities, we can see I've got a file explorer open, I've got Firefox open, and it also gives me like this dashboard type view when I click on activities. So I can see all of my open windows and I can maybe click on one to go to it. So there's a lot of really cool features about each desktop environment. We won't have a lot of time to deep dive into all of them, so I encourage you to just play around, find one that you feel matches closely with how you would like to use the computer. One really cool feature that I like is the fact that we can have virtual desktops. So let's say I clutter this one up. Maybe I'm working on homework on this one, and I need to come over here and maybe work on a different class. Maybe I'm going to look at some pictures on this one, and I can kind of keep my desktops separate to where maybe they're organized by theme or what program I'm working on, whatever. Okay, the other one I want to show is Ubuntu. So Ubuntu uses its own desktop environment called Unity. And it closely resembles GNOME 3. We got the taskbar over here on the side with all of our applications, and I would say this one probably reminds me more so of Mac OS or OS X's desktop environment, in that when we open up a window, so let's get this window open, the menu bar is actually at the top of the screen. So you see when I click in here, and if I want to do anything with the Firefox browser like file or tools or bookmarks, that's actually up here and it's not attached to the window down here. So that's something that Mac's done for years. Unity's picked up on that notion. There's some tweak tools that you can install that'll actually move this menu bar back down to the window so that if that's the way that you're more familiar with it, you can sort of customize your desktop environment to look like that. Now, open windows, we can see they're indicated with these little arrows on the side. So if I open up another one, then we can see some arrows there. So I see I have two open windows. There's a lot of different configurations that we can do. All right, so you may want to play around here in the settings. And if we minimize something, it just goes right back down into this icon. So we can see it's still open. We still got the arrow there. We just need to click on it to bring it back up. Alright, so those are just three popular desktop environments. There are several ones out there. It's very easy for you to for people to get one and modify it and then release a new one based on those modifications. And that's part of what's great about open source software. Okay, so these GUIs, what do they give us? What do the desktop environments allow us to have? Well, we saw program launchers, file managers, window controls, so the ability to minimize, maximize, and hide windows. Logout options, so we don't need to go into the terminal and type shutdown or power off. We can just use the logout option. So let me just show you here in Fedora. If you click this down arrow, there's a power button, and you can click that power button. It'll give you the option to power off, restart, or cancel. And Ubuntu is very similar, same sort of location up here, and we can go to shut down. It'll ask us what we want to do. All right, so what is open source, right? Open source is what Linux is based on. Essentially the source code for Linux is available for anyone to download, and anybody can compile that and run it and is free to make changes to it. So just some basic definitions here that we need to be familiar with. Source code. Source code is a file that contains the programming code for whatever programming language we're writing this in that humans write to create software. And a compiler is something that takes that source code and turns it into binary code. So binary code is the actual machine instructions that a particular processor runs. So a compiler will target a specific processor in order to create that binary code. A translator would be something like, if you're familiar with PHP or Python, those two languages take source code and they turn it into binary code on the fly. So they'll temporarily turn it into binary code in order to execute it. So we sometimes call those interpreted languages. Okay, binary code, we basically hit on what this is. This is code that the machine needs to run and understand software programs. So this is the actual binary, the ones and zeros. And that binary has a specific meaning to a processor, and that processor knows how to read that and execute the commands in there. And open source is just freely available source code. There's lots of places on the internet that we can, or that are hosting open source projects. We can go and browse through those. GitHub is a very popular one. Bitbucket is also pretty popular as well. So where does Linux fit in this whole world? Well, let's compare Linux to Unix first. So the Linux kernel is based on Unix. Specifically, as we saw in that little forum post by Linus, is that it was based on Minix, which is based on Unix. And it also uses the GNU project. So the GNU project was started by Richard Stallman as part of the Free Software Foundation, and its goal was to develop open source replacements for Unix core elements. So the Bash shell is a popular shell in Unix, and we have a replacement that's been developed by GNU called Bash. There's all of the commands that we use, like to move files, that ls command that we saw earlier to list the contents of a directory. Those are GNU tools, and we need those coupled with that Linux kernel in order to have a complete operating system. And then, of course, we need some way to display the GUI environment, and in a Linux-based world, that's going to be X11. So X is a Windows server that is used on Unix-based OSs to actually show that GUI or the desktop environment. Okay, so there's many open source desktop environments. Lots of them are available on both Unix and Linux and FreeBSD and other derivations of Unix, because it's very easy, since Linux is based on Unix, to compile some Linux code and have it run in Unix. So some examples are GNOME, like we saw in Ubuntu, KDE that we saw in OpenSUSE. XFCE is another one, so you can Google that and look at some screenshots of how it looks. We also saw, I'm sorry, I think I mentioned that GNOME was used in Ubuntu. GNOME was used in Fedora. Unity is used in Ubuntu. And there's other ones like Mate. There's GNOME 2, which is an older version of GNOME as well. Okay, so server programs. This is a big use case for Linux. A lot of A lot of servers that are out there providing the infrastructure for our internet are running Linux-based operating systems. So some examples that you'll find are web servers, email servers, and file servers. So next, what about productivity programs? We know that Linux and Unix-like operating systems can run similar programs. We can take that source code and target a different operating system if we want to. You are more likely to find support on the Linux-based distribution. It just has a larger developer base and more users, which means that they're tackling more of the problems that you come across. Okay, let's compare Linux to Mac OS X. So OS X is a Unix-based operating system as well. The user interface is different. So, the user interface that I have here is known as Aqua, and the programming perspective is known as Cocoa. Applications developed from OS X cannot run on Linux unless we heavily modify them. So some of the APIs that are used totally different. It's not going to be a trivial change to just go ahead and target a different OS if we're going to compile some software. OS X is limited to Apple hardware. That's not to say that there's not projects out there that get OS X to run on AMD processors and create things like Hackintoshes. But as far as official support, it's just the hardware that you can buy from Apple. Linux, however, runs on a wide variety of hardware. It'll run on things that you probably wouldn't think it could. Um, Very old processors it runs well and has good support, and very new processors as well. And how about comparing Linux to Windows? Well, one of the differences would be licensing. So Linux is open source, whereas Windows is closed source proprietary. So with Windows, if we were curious about how the login worked in Windows, we couldn't just go and download the Windows source code and open it up and take a peek, change it if we needed to, and recompile it and use that. With Linux, we can, though. We can get a copy of the source code. We can get a copy of the source code for these desktop environments because they're open source. And we can make modifications where we need to or where we see fit. So, what about cost? Well, Linux, obviously, the licenses are free. It's open source, so it's hard to really charge for that. The businesses out there that do charge for Linux, what they're charging for is for support. So companies like Red Hat and Oracle, they will sell you support packages and allow you to use their operating system with a little bit of proprietary software added, so software that we don't have the source code for. But basically they're leveraging Linux's open source software or its open source code. Windows, on the other hand, has costly licenses. The licenses can get very expensive, and depending on the amount of users and how many users are going to connect to that system or use software on that system, you have to have a certain amount of licenses for that. So that just makes it very expensive. But as far as expertise, so hiring people to work at the help desk or hiring an IT technician who understands how to use that operating system and debug it and figure out problems that are occurring, it's easier to find that expertise for Windows. And it's typically less expensive. However, for Linux, the expertise is a little bit harder to find and it can be a little bit more expensive because due to the fact that that expertise is harder to find, the ones with that expertise can command a higher salary. Okay, and then what about hardware compatibility? So as far as drivers, Windows, most companies provide drivers for their hardware when it comes to Windows-based operating systems. And usually that's about the same on OS X as well, because that's another major distribution that has a lot of the market share, although Windows definitely has the lion's share of the market share as far as operating systems used by end users. So, what's a real life example? If I buy a printer, I need to install a driver on my computer, and typically that company is going to provide a driver for Windows. They'll provide a driver for OS 10. Nowadays, a lot of companies are good about providing a driver for Linux, but that's not always the case. And sometimes we have to wait for the community to take the Windows driver and sort of reverse engineer it a little bit and come up with a driver that works in Linux. Older hardware, Linux runs better. So if you have a computer that's running Windows and it's just gotten sluggish, maybe it's 7, 8 years old, and you're thinking, well, this hardware is just obsolete, I can't use it anymore. There's a good chance you can throw Linux on there, and Linux just makes more efficient use of the hardware. It doesn't use as much memory as Windows and OS 10, so that leads to it running better on older hardware. So I'd encourage you, before you throw out that old machine, try putting a copy of Ubuntu on it or whatever your favorite distribution is and see how that runs. Okay, so software availability. When it comes to Windows, everybody's familiar with Microsoft Office. The big problem people have when they switch to Linux is Office is not available on there. There are ways that we can install different emulation layers that will allow us to run Office software, but it's probably in your best interest to just start using a natively compiled application like LibreOffice. Let's jump back over here into, I don't know if it's installed in Fedora, but let's jump into Ubuntu. I know that LibreOffice is included here. We can see it over here on the side. It's already pinned to the taskbar. We have LibreOffice Writer, which is like Word, Calc, which is like Excel, and Impress right here, which is a lot like PowerPoint. So when this comes up, you can see it has a very familiar interface. This looks a lot like an older version of Word. So before they started doing the ribbon bar up at the top. And this program is also capable of reading and writing files that are supported by Office. So if we go to File, Save As, we can change the format. Now the default format is going to be one of these open document files, or ODFs. That's just a native file format for LibreOffice, but you can see that there's other ones down here. So we can do a docx file. We can do one of the older .doc files. So that's just something to keep in mind. You got some compatibility here with your Windows counterpart software. And that allows you to collaborate with other colleagues that are using different operating systems. Now, sometimes I will say that the formatting gets messed up. I guess the way that Windows parses and looks at those docx files and the way that LibreOffice does it can sometimes differ. So do make sure that you take a look at your files. If you have a chance, open them up in Office and see what they look like, maybe before you do a submission or something for a professor. One way you can get around that, of course, is just to go to File and export it as a PDF. A PDF is going to look the same here as it does on a different operating system. So that's one way around that. In the Linux world, the Apache web server is very popular. Apache gets used more than IIS, which is Windows's web server. And you can see that in web stats. There's different stats out there that you can Google for to see, what is the majority of the internet using as their web server, and you'll probably find out that that's Apache. User interfaces. So Windows is proprietary. We know that. We just talked about that. Same thing with OS 10. And those user interfaces, we can't switch them out for other desktop environments. So I can't say, hey, I don't like Mac's Aqua interface anymore. I want to change it and use GNOME 3 here. That's just not possible. Sometimes you can theme it out and maybe get it to look different, but we're not going to actually be able to run GNOME 3 here on OS 10 or get the the GNOME 3 interface to run on Windows. On Linux, however, it's open source, it's standards based, so we can quickly install another desktop environment and it'll just switch up and we can start using the new one. Security and configurability. So Linux tends to be more configurable and flexible. That's going back to what I just mentioned about the UIs, and that if we don't like one, we can put another one in to replace the one that we're currently using. And a lot of Linux is modular like that, in that we can take pieces out and put other pieces in and sort of create our own product from that. Security also, so open source software tends to be more secure. The idea behind that is that there's more eyes on the source code. If let's say I'm a company and I'm creating source code, but I want to keep it proprietary and just within my company, then I might have a dev team of 20 developers, and those 40 eyes are the only eyes that are looking at the source code to try to figure out if there's any bugs. If I have an open source project and I'm hosting it on a site like GitHub or Bitbucket, then potentially the entire world can look at that code and they can say, hey, there's a bug here. I think I need to submit a request for you to change that or fix it, or here's my solution to your problem. Maybe you'll implement that. And also, Linux is used by the US government, so there's lots of DoD rules on security in different operating environments, and they also contribute back to the open source community with different security contributions. So, what is a distribution? Well, we've been talking about distributions, and examples of that are Ubuntu and Fedora and OpenSUSE. Well, a Linux distribution is a complete Linux-based operating system. So it's sort of everything packaged together. We have that Linux kernel, we need that. We need those core Unix tools. We need supplemental software like LibreOffice, Firefox. We need some startup scripts, some things that are going to start up that desktop environment and the GUI and run certain jobs in the background for us. And then we also need an installer, which is what we walked through when we set up the VM. We went through and had it format and partition the hard drive and to copy the files over for us. So it's all of those things put together is what makes a distribution. Here's a list of some common distributions. And the common distributions sort of come from two families. There's the Debian family. Okay, so we can see that listed there. So it doesn't go on. There it is, right up here. So Debian, and a lot of, due to the nature of open source software, a lot of operating systems will take code from Debian and then fork it, and they'll create their own. So they'll create something like Ubuntu, right? And then somebody might take Ubuntu's code and create something like Mint. So they're just taking code, making changes to it, adding things to it, and now it's a new product. The other main sort of distribution is Red Hat. So Red Hat, again, is one of the commercial companies. They'll sell you support and some proprietary tools to use in their operating system. There is a free version of Red Hat. It's the open source equivalent. And that's CentOS. So you could use CentOS. Based on Red Hat is also Fedora, and Fedora is sort of a test bed for new features coming to Red Hat. So before they get integrated into this commercial product, the company Red Hat also runs Fedora, and they'll create some new features and try them out there before integrating them in here. And then we have some other operating systems that aren't based on either one of those, like Gentoo or Slackware. There's also specialized distributions. So I'd mentioned earlier that Linux is very prevalent. It's running in a lot of embedded devices, things like TiVos, things like network appliances, Roku's, Amazon Fire TV sticks, Android, so on our cell phones. Linux provides the base for all of these different operating systems. All right, so lastly here, let's just talk briefly about release cycles. So a standard release, we have And you can see over here, what is the release cycle for these distributions? Well, some of them are rolling in that as soon as new software comes up, it's released and you can go ahead and start taking advantage of that. Others, such as Ubuntu, are on like a 6-month release cycle where at some point in time we freeze the packages and we say, okay, this is the version that we're going to use in this release of Ubuntu. And that's not to say that we don't get upgrades, because we still get upgrades, but those are security bugs that are getting applied. So any sort of vulnerabilities or things that could make our system crash, those will get backported into those versions that are used in those distributions. So we don't have to worry about, from a security standpoint, our release cycle. In fact, it's generally a little bit more stable to use one of these release cycles, like a 6-month or 2 to 3 year, an 8-month release cycle, as opposed to a rolling cycle, because these come out really fast and sometimes too fast in order to catch the bugs that they're going to generate. Okay, so it provides support for a stated amount of time. You can look that up on a distribution's website. At what point in time are you going to quit supporting this particular version? Software updates, they're made available for those security issues and then also for any bugs like crashes or logic errors in the code. Some distributions offer long-term support, so extended support. And in an enterprise, this is something that you would like. You want to be able to install software and you're going to have a server running for a few years. You don't want to be doing operating system upgrades every 6 months. You'd rather keep with the same operating system. So distributions release long-term support and they'll provide support for those bug fixes and security issues on a longer term. After the support time has passed, it's best to go ahead and upgrade to a new release, because at that point in time, you're not getting any more bugs and security updates, and you're going to leave yourself vulnerable to whatever's been discovered since then. And as I mentioned, rolling release, that software is just released continually. So as the upstream provider, whoever's writing that software, as they release new versions, those will get packaged up and made available for you in your rolling release distribution. Alright, so I hope this has demystified a little bit of the high level topics. The whole purpose of this course is to dive into some more of this content. So like I mentioned earlier, there's no labs or quizzes on this, just to give you some background information. So that's all I have for this video. I'll catch you guys in the next one. Thank you.